Just under 4 million years ago, one of the most significant events in recent evolution took place in an otherwise unassuming patch of woodland in what would one day become Ethiopia. An ape no taller than 5.5 feet descended from the trees towards the ground. When, however, its feet touched the long grass of the ancient African savannah, its hands did not. This was Australopithecus afarensis, quite possibly the first of our ancestors to be able to walk upright for an extended period of time, and a species that would go on to revolutionise the Pleistocene world with its descendants and relatives. This ape, of course, would eventually become us, Homo sapiens. Afarensis' research history is as extensive as the Great Plains in which this species first ventured into. Out on the grasslands, it was no mere race to the top. Australopithecus had to contend with some of the most fearsome animals of the Pleistocene as it spread out across sub-Saharan Africa, and domination of ecosystems were very much out of reach. As it evolved, however, Australopithecus would bring about great changes in the environments in which it lived, which would lead to later species, such as Homo habilis and Homo erectus, displaying the first clear signs that humans were here to stay, far and wide. Today, we will be exploring the natural history of this unique species of primate. We will be what this ape looked like, where and how it lived, and how it was ultimately discovered by its advanced descendants. Sit back and relax as we introduce you to Australopithecus afarensis, one of the very earliest human ancestors. A most unusual ape. If you were to come face to face with a living, breathing Australopithecus afarensis in the depths of the Pliocene and Pleistocene epochs, the chances are that, despite your differences, you would be able to see a little bit of yourself in the creature staring back at you. Unlike humans, this ape was covered in a layer of fur akin to that seen on modern bonobos and chimpanzees. It had a prominent brow ridge above its eyes, a sagittal crest atop its skull like a gorilla, and when fully grown, likely measured between 5 and 5.5 feet. These creatures are thought to have been highly sexually dimorphic, and you would likely be able to tell if you were looking at a male or female afarensis. Males were notably taller and bulkier than females, but further research on the weight of female individuals is needed to determine by how much on average exactly. Australopithecus afarensis was the first known species on the line of primates that would lead to humans that are notably more human-like than ape-like. The vertebral bones of these apes are roughly the same width as ours and would have helped them to walk as we do, standing tall above the dense grasses to get an advantage over any predators that might have been lurking in the undergrowth. The width of the vertebrae may also have played a part in permitting Australopithecus the dexterity and hand-eye coordination it needed to begin to manipulate its environment and develop its motor functions, ahead of its tree-bound relatives. Fragments of Australopithecus ribs that have been discovered in Africa show a distinctive bell-shaped rib cage that had evolved in this species, slightly different to the barrel shape that we possess today. Proportionately, Australopithecus afarensis' arms were much longer when compared to its overall body size than those belonging to modern humans. Some scientists have interpreted this as a retained adaptation that would have helped the apes climb through the trees when they needed to, for example, to escape approaching danger at ground level. Others argue that this was little more than a basal feature retained from its tree-dwelling ancestors that was in the process of being phased out by evolution to better suit a life on the ground altogether. Moreover, there are many similarities in Australopithecus' hands when compared to our own. Its fingers are highly flexible and could be curled to hold and manipulate objects such as stones and sticks with greater power and control than that of other apes. But it would likely have struggled with larger, more spherical objects due to the range of its grip. As notable an adaptation that walking upright is, Australopithecus afarensis was unlikely to have moved in this way all of the time. While the heel bones found in preserved Australopithecus feet show similar adaptations to walking, as our own skeletons, the big toe was still manoeuvrable to an extent. This feature, seen in tree-dwelling primates, can hinder an ape's walking ability while simultaneously make it easier for arboreal locomotion amongst the treetops. In the modern day, Our big toes have more or less lost that dexterous ability of, say, chimpanzees, but in a world where you're far from the top of the food chain, this may have been a lifeline. While Australopithecus afarensis was human-like, it was not quite a human. If we are to class all human primates as those belonging to the genus Homo, then Australopithecus was a predecessor on the line to humanity. It was a hominin and displayed many features seen in modern humans and apes, but there are too many differences between Afarensis and, say, Homo habilis to group this animal in with humans. It is, however, a vital step on the path to us, and one that scientists have learned a great deal about over their many years of studying the species. The discovery of a dynasty. While Australopithecus afarensis is a much better understood, and earlier, species of ape, its close relative, Australopithecus africanus was discovered and named first. In the mid to late 1920s, fossils belonging to archaic hominins in Africa were being discovered more and more frequently. The majority of these finds were assigned to Africanus, but as time went on, it became more obvious that there was more than one species of Australopithecine ape out on the grasslands of Africa during the late Pliocene and early Pleistocene. The first example of a fossil that would later be assigned to the new species, Afarensis, was a maxilla unearthed by Ludwig Cole Larsen, a German explorer, along the banks of the Gurusi River in Tanzania. The find was made in 1939, but it wasn't until 1948 that paleontologist Edwin Hennig proposed a new genus for it, Preanthropus. Over the next decade, paleontologists and anthropologists would experiment with the name and placement of this bone, discussing placing it in both new and established genera. All the while debate was ongoing as to where this bone should lie in the fossil record. Further discoveries were being made by the likes of Mary Leakey, Yves Coppens, Maurice Taieb, and Donald Johanson. These names are huge in the field of anthropology and the study of archaic humans, and these people would prove invaluable as scientists began to search for the origins of mankind in Africa. It wouldn't be long then before one of the most famous fossils in all of paleontology was unearthed. On 24th November 1974, Donald Johanson and his graduate student Tom Gray, whilst undertaking an excavation in Hadar, Ethiopia, struck gold. There, in the ground preserved for over 3 million years, was the most complete ancient hominin fossil known to date. They would call her Lucy, after the Beatles hit Lucy in the Sky with Diamonds, that played on the radio around their campsite that evening. About 40% of Lucy's skeleton had been preserved in the very spot in which she died, around 3.2 million years prior to her unearthing. Upon her discovery, she would become globally famous, as descriptions and reconstructions of her species began to flood in. Her bones would undertake a 6-year tour of the United States of America, and is now preserved in the National Museum of Ethiopia in Addis Ababa. Her skeleton is off show to the public, and a plaster replica sits in its place to avoid damage to the priceless fossil. At the moment, it is not known how Lucy met her ultimate end, as her skeleton doesn't show much evidence of predator or scavenging by the Pliocene Africa's numerous predators. She was an adult, but not elderly, and the only visible wound on her bones is a carnivore tooth mark to the left of her pubic bone. In 2016, an idea was put forward that Lucy died after falling out of a tall tree, but Donald Johanson disagreed with this idea, as there was not enough visible evidence of trauma or bone breakage that would be present in such a scenario. In 1978, 4 years after Lucy's discovery, her bones would be assigned to a new species, Australopithecus afarensis, with Afarensis honouring the Afar region in which her bones were unearthed. Following the establishment of the species, old Afarensis bones once attributed to Africanus would be reassigned, and more have been discovered since. More recent finds include partial skeletons across the Afar region, as well as a specimen discovered in 2015, discovered in the Woranso Mill paleontological site elsewhere in Ethiopia. Australopithecus afarensis has remained valid to this day, and scientists are continuing to learn more about this vitally important species. Newer discoveries, such as a cranium from the Woranzo-Mil region, discovered in 2019, may be much older than Lucy, dating back to around 3.8 million years ago. How did Australopithecus afarensis live? One of the key secrets to the success and survival of this species in the forests and grasslands of ancient Africa was its generalistic approach to feeding. Like us, Afarensis was a generalistic omnivore, eating a wide range of plant and animal matter. While the ape ventured onto the grasslands in certain populations, studies show it was in fact more at home closer to the tree lines, where a wide range of plant matter could be reliably sourced. A favourite food of this species was tubers, which they could dig out from underground. Succulent, water-rich plants may also have been taken where possible. On the savannas, Afarensis would seek out grasses, which it could chew with its hardy teeth, coated in a much thicker layer of enamel than our own. Seeds and roots, as well as fruits in certain regions, would have supplemented this. It is speculated that Australopithecus afarensis, like modern-day great apes, may also have sought out colonial insects, such as ants and termites, that would have been available in large quantities in one sitting. Evidence also exists to suggest that Afarensis had a taste for meat, when it could be obtained too. In 2009, the Dikika paleontological site in Ethiopia rewarded scientists with a broken femur of a young bovid, possibly an antelope, that bore several unique marks along its flank. These were not randomly inflicted by a careless Australopithecus, but were in fact linear cut marks inflicted with the intent of splitting the bone at a certain point. Other marks on the femur may indicate that a stone was used to crush it, perhaps in an attempt to obtain the marrow within. If this is indeed the case, these 3.4 million-year-old dents would be the earliest known example of butchering in the fossil record, and could only have been made by Afarensis, given the time and place they are from. It is unlikely that Australopithecus killed the animal in question, as their tools were not specifically designed for hunting. Rather, this appears to have been an attempt at scavenging meat that had already been killed by a large predator. How common this behaviour was is unknown, but the varied diet of these apes may have given them the edge over other, more specialist species in ancient Africa. The stone tools that Australopithecus afarensis used to break into bones and termite nests were very simple by the standards of later species, and are not thought to have been modified or manipulated in any way ahead of their use. Unlike many of the apes before them, they were able to recognise that if an angular stone was brought down hard enough upon an object containing food, that object could snap, and a quick meal could be earned. Jagged rocks, small enough to fit into the palm of an afarensis' hand, were likely the most commonly used example of tools by this species. But long, thin twigs and sticks may also have been utilised to coax insects out of their nests. Of course, technological capabilities would be enhanced to no end as later species appeared on the scene, but we had to start somewhere, and this was a good place to do so. Afarensis' hyoid bone was structured in a way more akin to chimpanzees and gorillas than modern humans, which means that these apes were still far from being able to develop complex words or language. Rather, they likely expressed themselves using a variety of whoops, hoots, grunts, screeches, or shouts, similar to the way modern great apes communicate. Social behaviour or structure is hard to determine in species this old, but given the levels of dimorphism present between males and females, scientists have theorised that, like us, they were extremely social animals. Modern great apes that show dimorphism, where the males are larger than the females, tend to be led by a dominant male, and this theory has been put forward for Afarensis. Speculating, a male may have been in charge of a troop of individuals, where he may have had the right to mate with the females in his immediate circle. Challenges from rival males may have periodically arisen, seeing old males cast out or replaced. This being said, Australopithecus afarensis' canine teeth were comparatively small, which is usually a good indicator of male aggression in primates. Perhaps they were much more peaceful than we might think. Regardless of how peaceful they were, Australopithecus afarensis' lifestyle appears to have taken its toll on their bodies. Many individuals have been found to have been hunchbuckled in life as they grew older, which may show that these apes were still developing the spinal columns needed to support a life on two legs. Overstraining of the back over time led to curvature of the spine, with several known individuals, but this is not to say that Afarensis wasn't adapted to this new way of life. Excessive locomotion in modern humans can lead to straining and muscle damage, and the same may simply have happened here. Other Afarensis specimens have been discovered with fractured ankles and legs, and one catastrophic incident appears to have killed several individuals in one sitting. This incident, potentially a flash flood, buried the apes on a hillside quickly, and as a result of their concealment from scavengers, are very well preserved. Another less accepted theory, however, states that surviving members of the group may have cached the bodies in one place away from their home grounds. This way, diseases and predators brought about by their dead would not pose a threat to the living, but this theory is yet to be proven. A deadly world. Australopithecus afarensis tended to frequent a wide range of habitats across East Africa, and the species seems to have been at home everywhere, from dense forests to open grasslands. In between, the apes would have encountered freshwater wetlands and swamps, dry shrublands and fast-flowing rivers, each of which posed benefits and threats. In Afarensis' day, the rainy season was much more pronounced than it is in modern times, which would have led to seasonal foraging of different food types depending on what was available. While these apes did indeed manage to survive and evolve into later hominid species, Africa was much more varied in its roster of large and deadly carnivores in the Pliocene and Pleistocene, and Australopithecus was a relatively easy target. The biggest threat to Australopithecus, as well as almost all the hominid species that have evolved after it, were big cats. Leopards would have been deadly terrestrial, and arboreal hunters that could drag their catches into trees and strike with terrifying silence, while others, of the saber-toothed variety, were at their peak during Australopithecus' day. Dinophelis, Meganterion, Homotherium, and Machaerodus were all large, powerful cats with strong jaws containing teeth that acted like knives, piercing the skulls and necks of apes whose backs were turned at the wrong time. At the water's edge, when Australopithecus came down for a drink, it needed to be wary of the various species of crocodilian that lived in the murky rivers and lakes of East Africa. Crocodiles are some of the most widespread and accomplished predators in our waters today, and can drag prey much larger than themselves beneath the surface with relative ease. Once a crocodile ensnared an unlucky Australopithecus in its jaws, it was just a matter of time once the infamous death roll began. Hyenas were abundant on the plains too, acting both as scavengers and predators. Extinct hyenas, such as Chasmoporthetes, would have been a major threat to Afarensis if it found itself straying too far from the safety of the trees, while modern species in the genus Crocuta would have proven just as deadly. There is also evidence to suggest that young Australopithecus may have been at risk of attack from above. Many large species of predatory birds, primarily eagles, could swoop from the skies with little warning, claws first, which would have made quick work of a young ape's skull. Australopithecus afarensis also would have come into contact with some of the most awe-inspiring herbivores ever to evolve. Late surviving calicotheres such as Ancestor, bizarre ungulates that resembled horses, may have crossed paths with these apes, as did Dynasty, a large relative of modern elephants with sharp, backwards-facing tusks. Much of the megafaunal species we are still lucky enough to have on the African plains today, such as rhinoceroses, elephants, giraffes and zebras, would have been around in Afarensis' day, each of which would have played a part in supporting the ecosystem in which our ancestors lived. Australopithecus afarensis was, as we all know, far from the last stop on the road to Homo sapiens. Around 2.9 million years ago, the species disappeared from the plains of Africa, and in their place were new breeds of upright ape, ones that would go on to conquer the wider world outside of Africa. Australopithecus afarensis would lead to Homo habilis, who would in turn eventually give rise to Homo erectus, and then to us. Along the way, they would have experienced complications, innovations, danger, and excitement, all of which contributed to what makes us, us. With any luck, scientists will be making discoveries about this species long into the future.